Proof and usage of DI method, and DI stands for differentiation and integration. So in this method what happens is if you have a product of two functions, basically use integration by parts. Yeah, and this is just same, or let's simplified or made easier to look at. Yeah, or made easier to analyze, the such version of integration by parts. Yeah, this is just the integration by parts, but just made easier to use. Yeah, this is DI method, because this is called DI because we have differentiated here, integrated here, differentiated, integrated. And in this method what happens is we first take f, yeah, and we write the function f, first derivative of f, second derivative of f, third derivative of f, and take g and write first integral of g, double integral of g, triple integral of g, four integrals of g. Yeah, and then distribute signs. First of all, minus and then plus, and then minus and then plus, and then minus and this plus. So this is how we use our DI method to solve integrals. First of all, let me show you the use of DI method and how much simple it makes the integration, and then I will give you the proof of DI method. Yeah. So let me show you how it makes our work easier. Let me take this integral. Yeah. So now, if we have to use integration by parts, let me show you how we do it. This will be x to the power 4 and then integral of e to the power x, e to the power x minus integral of 4x cube times e to the power x is the integral of e to the power x dx. Now again we will use integration by parts. This will be 4x cube as it is, and then integral of e to the power x plus integral of, there will be derivative of 4x cube is 2x square times e to the power x is the integral of e to the power x dx. Again we will have x to the power 4 e to the power x minus 4x cube e to the power x, and then we will have 12x square as it is, and the integral of e to the power x e to the power x. Again this plus was because minus and minus multiplied to give plus, but now plus and minus will give minus. Integral of the derivative will be 24x. Yeah, and the integral will be e to the power x itself. Yeah, dx. Now x to the power 4 e to the power x. Now basically we have to do a lot of steps using integration by parts. Yeah, but the same thing is there in DI method as well, but it will help us to do in the single step. And now 24x as it is, and the integral of e to the power x, e to the power x, and then minus minus will be plus, and then we will have integral of derivative is 24 itself, integral of e to the power x, e to the power x dx. Yeah, and now we will have x to the power 4 times e to the power x minus 4x cube e to the power x plus 12x square e to the power x minus 24x e to the power x plus, this will be 24, yeah, times e to the power x integral e to the power x, and minus, if you try to differentiate this again we will just get 0. Yeah, so now whatever it is, it will just be 0, so we cannot really continue further, so we have to end our integration by parts procedure here. Yeah, because all of them after this is going to be 0. So this is the answer. This is the answer, and it took us 1, 2, 3, 4, 5 steps. But if we use DI method, yeah, this will also give you an idea of why DI method works. This will also give you a slight proof. Yeah, first of all, this is our f of x, and this is our g of x. Yeah, so we have f of x here, and there is g of x. Yeah, so this is f of x. This is first derivative of f of x for x cube. This is second derivative of f of x. Yeah, sorry. Okay, and then this is third derivative. This is fourth derivative and continuous, but here since this is 0, there's no value in continuing because there's no meaning to continue because it's 0. And similarly this is integral of g of x, no, this is okay. So this is integral of e to the power x basically, and this is double integral. Though it's same because it's e to the power x, and it was triple integral. Yeah. First of all, it was integral over here, and the integral of integral is here. Integral of integral is here. Yeah. You might have noticed that during the process, and this is integral of integral of g, and this is integral of g. So this also gives you an idea of the proof of DI method. Yeah. And if you want to do it rigorously, so I have basically shown you like how it makes life easier. So if we use DI method, we would just do like this. First of all, x4, and then 4x cube, and then 12x, and then 24, and then 0, and so on. Doesn't matter. Sorry, this is 12x square, this is 24x, and 24, and then 0, 0, 0 doesn't matter. And for e to the power x, integral of e to the power x is e to the power x yourself. And notice that for derivation, like we don't like take derivation in the first step, but we do integrate. Yeah. Over here we have first derivative, but we have double integration. So please notice that thing. Yeah. Like don't differentiate it at the first step itself. You can note that from the integration by parts formula itself, because we don't differentiate at the first. We just write f integral of g minus like derivative of f, and then integral of g. Yeah, so we don't differentiate at the first step, but we do integrate. You can note this from the integration by parts formula itself. And now integral of e to the power x, and double integral will be e to the power x again, and e to the power x again, and e to the power x again, e to the power x again. But after this, there's no value, and sign just alternate. So you see, same thing, but through integration, but through DI method, we can do it in single step. So that's the benefit. And now let's go to proof. Proof is similar because you already have the idea from the solution itself. What we do is we first write f, and then integral of g minus integral of derivative of f, integral of g, and then dx. Yeah, again we have f integral of g minus. Now again we just first of all we write like the same f. Yeah, we write this same. And now how do we do this? So this will be integral of g. Yeah, so whatever we have over here, we have to integrate that in integration by parts. Yeah, whatever the integral of g is, now we have to integrate that in integration by parts. So that will be integral of g, and minus minus will be plus. Yeah, and then we will have integral of derivative of f dash, that will be double f, and then we have to integrate this thing over here. Yeah, and so that will be integral of g. Yeah, again minus f dash integral of g plus. Now this will be, write it as it is, and now integrate this other thing. The other thing will now be triple integral, and minus integral of derivative of this is f triple derivative, and integrate this thing over here, that will be triple g. And this continues like this, it continues on, so on and so on, and that proves the statement that we have nothing, first integral, first derivative, second integral, second derivative, triple integral. Yeah, and sign is changing. So this proves the statement of DI method. Yeah, and let me like do another example as well, and then we will end the video. Let me see, another integral can be something like this: x cube sine x dx. Now for this, first of all write x cube, and then 3x square, and then 6x, and then 6, and then 0, 0, 0, doesn't matter. And over here, integral of sine x minus cos x, integral of minus cos x. Yeah, integral of minus cos x minus sine x, integral of minus sine x again, integral of minus x. So for double derivative, you can just integrate the for double integral, you can integrate the single integral. This is single integral. Yeah, and again if you integrate this, this will be double integral. And again if you integrate this, this will be the triple integral. If you integrate this, that will be the 4 integrals. Okay, so here, not here. Okay, now minus sin x, integral of minus sin x is just cos x. Integral of cos x is just sin x. Yeah. Now keep the sign. So minus, plus, minus. Now we can write the solution, and see, this should have taken 4 steps in integration by parts, but single step over here. So we will have minus x cube cos x, that will be plus 3x square sin x, plus 6x cos x, and then minus 6 sin x, and then plus, don't forget the plus c as well. I should write here plus c as well, I forgot that. Don't forget the plus c, and also over here also don't forget the plus c. Yeah, okay, basically the plus c can also be okay, fine, plus c. Now I hope you got an idea about solving problems using di method, why does di method work, the proof of di method, and yeah, I hope you will enjoy using this method. And if you want like other similar videos introducing some advanced integration techniques, you can check a playlist over here. Yeah, and do enjoy problem solving. Thanks for watching.